So hopefully a quick video here about generating the timing diagram for Software Lab 4. So you have this list of traces here in the lab document, and we're going to put the clock on top. In this case, that's fine. And otherwise, if you can keep them in approximately this order, that would be good so that I have an easier time keeping track. But we're going to put the clock pin on top here. Now, unfortunately, this particular program seems to be Windows only. I'm going to use it just to get some nice drawings for us here. You can also draw it by hand or open up an image editor and construct it. But if you have Windows or can install, if you're on Ubuntu, you could try running it through Wine or similar types of things. Try to get a Windows program to run. In a virtual box or something like that. But I'm going to open up a new file here. So I'm going to start a new file. For the particular operation I'm going to perform, I'm only going to need 2 clock cycles. So I'm going to leave this in place, and so I click on this, and I'm actually going to need so I think I can, okay, I can click on this, and yeah. So I have 1 rising edge, 2 rising edges, yeah. Okay, so we've got our clock here, and then I'm going to add, oops, I don't actually need that, get out of there. So I'm going to add a couple signals, and you will be able to edit the name just like this. There's a button right there for editing text labels. I'm going to pause it in a second, but we're going to start putting these in order. So this is going to be address bit 0, and I'm going to continue constructing these, but I'm going to pause the video while I set these up. Okay, back with these. I can't remember if I mentioned you can draw this by hand. In this case, I don't mind, because there's a lot to keep track of here. So the other thing I was going to do is, in this picture, it's starting high, which is not what we're going to have. So I'm going to take a little bit off of the delay, and oh, there it is. Okay, so I want the delay to be 3, I think. Hey, come on, update the delay. Apply. Okay, there it goes. All right, then we've got 2 rising edges for the particular operation I'm going to do. And so upon startup, most of these are going to be sitting low, but I am going to, in just a second here, prepare what this will look like. Oh, and I need to fix that. All right, so before we start going with our circuit here, I'm just going to fill various values in here for our imagined preloaded read-only memory. So we'll pretend that these are the values that were always sitting here, and now we're ready to start making sure that our timing diagram is working out. All right, so in our timing diagram, there's kind of a split here. So we've got the operation selects, the ALU input, this clear input, input, output, read and write. These are all things that we have direct control over, so we're going to control these. And at the moment, they're all set to 0 upon startup, so we don't have to worry about changing those. Then up here, we have the contents of the data bus and the addressing circuit. So let's take a look at both of those real quick. All right, so our default device address, it starts out at 0, which means that the address pin 0 is automatically a 1 upon startup. So let's modify that. Okay, so to modify this, I'm just going to bring the address bit 0 high for now, and all of these other ones were low. And I'll be readjusting this later, but I probably shouldn't have brought this all the way through, but Unfortunately, it's slightly annoying about this, but yeah. So let's just say that it's initially high, and then we're going to modify everybody ourselves. So the address bit is high, and then we also need to check on the data bus. At the moment, the data bus doesn't have anything on it. And if we go peek at that, that's confirmed. So when you are drawing it by hand, you can kind of scribble through it a little bit. At the moment, there is nothing on the bus. So for my purposes, I'm just going to go to the data bus, and I'm going to put this gray on it to indicate that there's nothing on it. It's in high Z mode, but you can kind of indicate that however you want. But now, while our clock is sitting low, we need to line up everybody for the computation we're about to do. So I'm going to switch over and I'm going to draw the computation that I said I was, or that I'm going to say that I'm going to do. So in this case, what I would like to do is take write-only memory 1, and I'm going to plug into it. We're going to take the NOT operation, and I'm just going to put ROM, let's say ROM 3. So I'm going to take the logical NOT of ROM 3, and I'm going to plug it into write-only memory 1. So at the moment, our clock is going to sit low, and I'm going to prep everything to take the logical NOT of ROM 3. So to allow that to happen, so all at the same time here, while the clock is sitting low, to prepare to take the NOT, I need to point to ROM 3. I need to put us into read mode. I need to not be clearing this register. This ALU register is going to need to pick up the new value. The contents of ROM 3 are, we're going to take the NOT through the A, because that won't require an additional clock cycle. So the number we want to NOT is going into A, so we need NOT A, which is code 7 here. So let's update that. And we're currently taking logical NOT of A. The computation is just about ready to do. Oh, so we're actually not loading anything into this ALU register because the C is running in this direction. So we actually need to input the accumulator because NOT of ROM 3 is ready to be remembered. It's the valid result of this computation. So our first clock cycle is going to require us to clock this number in. And ROM 3, we can see, is the value which is being pointed to by our address, putting it onto the bus, putting its contents onto the bus. This value is running here. We're performing the NOT operation, and we're ready to go. So before I go any further, I'm going to update all of those pins on our diagram here. So what's changed? Well, we changed the address. So this bit is going to go low. We're currently pointing at address 3, so I'm going to bring that high, which is accurate to what our diagram is showing. The data bus now contains this number. So of course in your case, there's no, you got to decide what was on that read-only memory. In my case, that means at the moment, the data bus contains the number 3, which is a 1, 1, 0, 0 in the least to most significant. Okay, so we've got that accurate. And so all in this same column, at the same time, I'm updating all of these pins. So okay, so we accounted for the address lines, we've accounted for the data bus. So what else did we change? We put the read line on. was one of our changes, so let's activate the read line. We activated the input to the accumulator. As we can see here, we made sure that the clear is inactivated by bringing it to 1. So I'll put that up. The operation select, we changed to perform the not operation. So now our selection is 0, 1, 1, 1 for the operation select, which means that's where those ones are. ALU input A/B prime. Right, it's pointing in the B direction now. Oh, my demux, I forgot to flip it. Right, hang on one second. Okay, sorry, the demux in the circuit that we designed had B on top of A. So now it's pointing the wrong direction. I actually need to flip this over to make everything work. So ALU input A/B prime goes to 1 if this is B and this is A. We want A to go to A over here and B to go to B over here. This was the correct order. So that needs to flip as well. So we'll turn that on. And then I think none of these other ones changed. And so everything is now accurately lined up. Okay, and so then these values, so now I'm about to flip the clock. So right before I flip the clock, I need to extend this over at least one more position to the clock edge here. And so I made everybody set up while we were low. Now the clock edge, we're going to clock this 3 into the accumulator. So we're going to zoom out because we want to watch for what changes. So I'm going to clock this. And the only change is the contents of the accumulator, which is not any of the things we were keeping track of here. So it didn't change the address, the data bus, the write, the read, any of these control lines. So nothing actually changed on this rising edge. But we have these input values, and so now I'm going to lower the clock, and we're about to store this data somewhere. But I've lowered the clock, and so everything that we had in the picture is still the same as the clock fell again. So until we reach the middle of the clock here, I'm just going to copy these over. To the middle of the clock. And so this is the moment where we're going to make further adjustments. So there's the timing diagram so far. Now over here, I need to take that result, and I said I wanted to store it to write-only memory 1. So we turn off the read, we turn on the write, and we need to point to location 1. So I'm going to stop moving things for a moment and make sure that this is caught up. So we changed our address marker. It stops being 3, and it will begin to be 1. So I'll bring that up there. The write line is high, so I will activate the write line there. So let's see. So we changed those. Once we took the read line off, well, we're going to make a couple more modifications. So I'm not going to put in the data bus until I finish changing the control lines. So at the moment, it actually doesn't matter which direction this is pointing, because the accumulator has the value that we need to know. So we're not going to change the accumulator, but we are going to output it. And this clear thing needs to stay high, so we'll keep all of that. So the clear, we're not going to clear it at all, so I'm just going to make this high the whole time, this one right here. So we brought the read low, we brought the write high. We need to output the accumulator. By outputting the accumulator, now the data bus contains a 3, the knotted value there. So now the data bus oh, I swapped these, didn't I? Yeah, it contains a 1, 1 now. Before it was carrying the C. Yeah, I reversed these, sorry. Right, so the data bus was carrying a C at that point. Well, it was reading the contents of address 3, because again, that was this C. So I accidentally swapped those. So now the knot of this, unsurprisingly, should be zeros and then ones there. And what else have we done? We didn't mess with that. Or, well, the input to the accumulator is low. That stays high. That's low. That's high. We're about ready to clock it, I think. Yeah, we just need to change our address. It's pointing to 1. We're writing. So we're ready to write only memory here. So address, data bus, write, read, ALU input. The operation select doesn't really matter either. I didn't change it, so it's still at 0, 1, 1, 1. It doesn't really matter what it is because we're not using the ALU anymore. We're taking the register value, putting it onto the bus, and writing it. So it's irrelevant. I could leave this low, but in this case, we're just leaving these high, so I'll just mark it that way. But it doesn't really matter what the op is, what the operation select for the ALU is if you're not storing the contents of the ALU anywhere. So the accumulator has it. We're outputting the accumulator. These are the control lines. I think that's everything. So I'm about to clock it, so I'm going to run back here. And so until the rising edge, so I just need to extend all of these by 1, if they haven't been yet. So there's our rising edge, so now I will raise the clock. The only move that should make is the RAM will change values, or sorry, the write only memory 1 will change values, and then yeah, the contents of the write-only memory is done, but that's the only thing that changed, and it's not anything we can see. And so we don't need to do another rising edge. We've finished the number, so we can just extend these off to the end. And that's it for this particular thing. So those were the things that we needed to do, that in 2 clock cycles we retrieved the read-only memory value in position 3, which put something onto the data bus. So we read that information. We had to store the result into the accumulator after selecting the not operation for the ALU. We made sure not to wipe those registers with the clear line. And we just had to ensure that our pathing was accurate so that it was definitely sending the C value, the value in memory location 3, which we could see on the data bus here. So the C was being sent in the A direction here. Technically, at the moment, I think I left the ALU input on, so I could actually extend this all the way over. It doesn't matter at the second half because we're not using that information, but we loaded the information in. Then a number of things didn't matter, but was critical. What was critical is that we pointed to location 1. We wrote the value from the output of the accumulator into memory location 1. So that was the extent of the timing diagram. And so there are a couple of particular ones that I expect you to demonstrate as timing diagrams to show that you are following what it does. But that's about it. So I'm going to close this video out and upload it to Canvas. Have a good day, everybody. I saw there were some Canvas messages I need to answer, and I'll be doing that right now, but I wanted to get the material up for everybody first, and now I will start looking at emails a little bit later this evening. So have a good day, everybody. Bye-bye.